Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the GCE Mechanics M1 Edexcel paper from June 2019. Here we're told about a car which is moving with constant speed along a straight horizontal road. Whenever the brakes are applied, they produce a deceleration of 5 meters per second squared. The driver sees a stop sign which is at the point S on the road ahead. Unfortunately, due to the time he takes to react, he does not apply the brakes immediately and the car overshoots the sign. Had he applied the brakes 0.5 seconds sooner, the car would have come to rest at S. The car is modeled as a particle. We've got to first show that at the instant the car passes S, the speed of the car is 2.5 meters per second. So basically what we have here is a road and the car and a stop sign. Okay, so this is the car, this is the stop sign, this is the road. Alright, so the car sees the stop sign, he takes a bit of time to react, and then he applies the brakes, and he doesn't quite stop in time, so he overshoots the stop sign and he stops somewhere past the stop sign. So he stops here. So say this is A, where he started, say this is B, where he stopped, and this is the stop sign. Now we've got to find the speed of, or show that the speed of the car is 2.5 meters per second when he's passing by the stop sign. Now the key here of this question says, had he applied the brakes 0.5 seconds sooner, the car would have come to rest at S. So basically what they're saying is that he's going to come to rest at B. If he applied the brake 0.5 seconds sooner, he would have come to rest at S. So the distance that he's going to travel, okay, in that 0.5 seconds that was too late, is the same distance between S and B. Okay, so what we can say here is that the speed here is 0 meters per second. The speed here is what we have to find. Let's call it U for now. All right, that's what we have to find. And we know that the time between these two is basically 0.5 seconds. So the time between S and B is 0.5 seconds. So if we consider the section of the journey between S and B, we have here a deceleration because the brakes are being applied in that same section here and produces a deceleration of 5 meters per second squared. -5 because it's deceleration. So if we consider between S and B and see what we have in terms of suvat, let me just make a bit of space here. What we have in terms of the suvat values, always I like to write down SUVAT when we have these constant acceleration questions. We can use suvat because we have constant acceleration here now, which is a deceleration. So S is the distance between S and B, which we don't know. U is the speed that we're trying to find, the speed of the car when it's at S. V is its final velocity, which is 0 meters per second. That's the velocity at B. A is -5 meters per second squared. That's the constant deceleration. And T is 0.5 seconds. So we have to find U. We have to show what U is. So we need to deal with U and V and A and T. So we can see V equals U plus AT. We have to know the equations of motion. Very important for us to know them. Okay, V equals U plus AT is going to be used for this. So we know that V is 0. U is what we have to find. That's the speed at S, plus -5, which is the acceleration, times 0.5. So we'll have 0 equals US minus 2.5. Therefore, the speed at S is going to be 2.5 meters per second. Okay, so you can say the speed at S, which I've called US, is 2.5 meters per second. That's what we had to show. Okay, so there's part A of this question done. Now we're going to move on to part B. Now it says, find how far the car travels past S before coming to rest. Okay, so basically we need to find the distance SB. We have to find what SB is. Okay, the distance between S and B, the stop sign and where it comes to rest. Let me write that a bit neater. Okay, and we can use this information here because this is between S and B. So I can just use this information here, and I can think about which equation to use, because now we have, in fact, more information than we actually need. All right, because I know U, I know V, I know A, I know T. I can use any one of the equations of the motion which have S in it. I could use S equals UT plus a half AT squared. I could use V squared equals U squared plus 2AS. I can use the average speed times the time is the distance. So I could use that. That's going to be probably the easiest one. U plus V over 2, the average speed times the time. That's probably the easiest one to use, no squares involved. So I'm going to use that. But somebody might ask, oh, couldn't I use this V squared equals U squared plus 2AS, whatever? Yes, you could. But, you know, I'm using this one because I find it easier. All right? So, you know, if you want to use another one of the equations, that's perfectly fine. You would get the same answer. And I'll illustrate that at the end of this. So U plus V is going to be 2.5 plus 0 over 2 multiplied by the time, which is 0.5 seconds. And that will give us the distance between S and B. Okay, so we have here 2.5 divided by 2 multiplied by 0.5. That gives us 5 over 8, which is 0.625 meters. That's the distance between S and B. There's the answer to part B. And just to illustrate it to you, supposing we decided we want to use V squared equals U squared plus 2AS, for example. We know V is 0. We know U is 2.5, so that's 2.5 squared plus 2 times A is minus 5 times S. So if we used this to work out what S is, SB, the distance between S and B is, you'll have, this is going to be, that's going to be 10. 2 times 5 is 10, negative 10, so that'll be 10 SB equals 2.5 squared. Therefore, SB equals 2.5 squared divided by 10. So if we find out what that is, 2.5 squared, 2.5 squared divided by 10, and you see you get exactly the same answer, 0.625. So it really doesn't matter which one of the equations of motions you use. In this case, you could use any one that you want. I think this is easier, so I use that. That's perfectly fine. So there's the answer to part A and B, and now we're going to go on to part C of this question. Now for part C, it says, at the instant when the driver sees the sign, the speed of the car is 64.8 kilometers per hour. The total time from the instant when the driver first sees the sign to the instant when the car comes to rest is 4.2 seconds. Find the total distance traveled by the car from the instant when the driver first sees the sign to the instant when the car reaches the sign. So let's say A is where he first sees the sign. So what we've been asked to find here in this question is we've been asked to find this distance here. This is between A and S. That's the distance we're asked to find. Okay, that's what we need to find. Now, this distance is made up of two parts. You have the part where he's traveling at this speed. Now, I'm going to change this speed. I don't like the speed in kilometers per hour because all our work is being in terms of meters and seconds. So let's change this into meters per second. So to change this to meters per second, we have to multiply it by 1,000 to change kilometers to meters. Okay, so you multiply by 1,000 and then you divide by, well, we want to change from hours to seconds. So you have to multiply by 60 squared, but because it says per hour, you have to divide by instead. So you're going to have divided by 60 squared because hours to minutes times 60, hours, minutes to seconds times another 60. But because it says per hour, it's like underneath in the denominator, you divide by 60 squared. Now that should give us our speed in terms of meters per second. So let's work out what that is. You have 64,000 over 60 times 60 squared, which gives us, hold on, 64.8. Sorry about that. Read the question carefully. Let that be a lesson to everyone. 64.8. So you have 64.8 kilometers per hour is 64.8 times 1,000 over 60 squared. So be careful not to make mistakes like that. You're throwing marks away for no reason. 64.8 times 1,000 divided by 60 squared. That gives you 18. So that's 18 meters per second. That's better. That's more how we like it. So at A, it's traveling at 18 meters per second. At B, it's traveling at 0 meters per second. At S, it's traveling at 2.5 meters per second, as we found out in part A of the question. Okay. And all right, so that's what we know so far. But what we know is that it took a certain time for the person to react, okay, before they applied the brakes. So in the time before he applied the brakes, he's going at a constant speed, okay. The speed is going at 64.8 kilometers per hour, all right. So let's say the car traveled a certain distance, okay, and it came to rest, or not came to rest, a certain distance before he started braking. Okay, supposing he started to brake at this point here. So it's still going at 18 meters per second at this point. And let's call this point C. All right. So we need to find the distance that this car is traveling in this section here between A and C. And we need to find the distance that the car is traveling between C and S. Okay, so this is, let's call this the S1 and let's call this S2. All right. Now, how do we find those values here? Okay. Now, what we can do is I can find out what the time is that it takes for it to go from this point to that point, because I know the initial speed, the final speed. Okay. I also know the acceleration, which is, the deceleration is -5 meters per second squared. Okay, I know that. And so I think I can work out here how long it takes for it to go from here to there. All right. And therefore, I can also work out how long it takes to go from here to here. Let's work that out. Let's try and work it out. We need to find those times, then we can find the distances. Okay. Let's see what we can do here. So for this, we don't have enough information. We need to have more information for this. So let's find out from here first. So let's consider between C and S. Let's see what we have in terms of suvat. Now, this is S2. U is 18. V is 2.5. The acceleration, okay, I also know, by the way, that the time between here and here is 4.2. And the time between here and here, okay, I can work that in one problem. Let's just work out what that time is first. I know the acceleration is -5. Okay, so, and I know the time is what I want to find. If I find that time, it will help me to work out what I need eventually, which is S2. Okay, so one second, I can even work out what I need from here anyway. But yeah, let's work out the time anyway. We know that V equals U plus AT. That will help me find the time. I've got these three. So V is 2.5 and U is 18 and A is -5 and T is what I'm trying to find, the time between C and S. I'll put CS. I'll put TCS, the time between C and S. Okay, so that's going to give me 5T equals 18 minus 2.5. So I can say the time between C and S is 18 minus 2.5 divided by 5. Okay, so the time between C and S is equal to 18 minus 2.5 divided by 5, which is 3.1 seconds. That's 3.1 seconds. So between here and here is 3.1 seconds. So the time between C and S is 3.1 seconds. And I know the time between A and B, the whole thing until where it stopped, it told us here, that's 4.2 seconds. Okay, that's 4.2 seconds. And the time between S and B, we know from the first part, is 0.5 seconds. Okay, that's 0.5 seconds. We learned that from A. So we can work out, therefore, the time between A and C. So the time between A and C, the time it takes for it to go between A and C, is going to be basically 4.2, which is the whole thing. Take away the time between these two, which is 3.1, and take away the time between those two, which is 0.5. So the time between A and C is going to be equal to 4.2 minus 3.1. What's going on there? 4.2 minus 3.1. Come on. Minus 0.5. 0.5. That's 0.6 seconds. 0.6 seconds. That's the time between A and C. All right, so now let's consider between A and C. We have constant speed. Okay, so here you have the acceleration is equal to 0. That's 18, that's 18. So that's pretty simple for us to work out. If it's got constant speed, we know speed equals distance over time. So we can work out the distance. The distance, which is S1, is equal to the speed times the time, which is 18 times 0.6. So 18 times 0.6, that's going to give you 10.8. That's 10.8 meters. So we say S1 is 10.8 meters. Okay, so that's this distance here. That's 10.1. Okay, so that's 10.1 meters. Now we got to find what S2 is. So we can use the values we know from between C and S. We know this is now equal to, between C and S, we know this is 3.1 seconds. So again, we're spoiled for choice. We can find from C to S, we can use these values. We can find what S2 is. We can use the average speed, which is, we can say U plus V over 2 times T, the average speed times the time. That's going to be 18 plus 2.5 divided by 2 multiplied by 3.1. That will give us the distance S2. Okay, we could use any one of the equations. So again, some people say, oh sir, why can't we use V squared equals U squared plus 2AS? Or why can't we use S equals UT plus a half AT squared? Or whatever. Sometimes there's different ways of doing it. Yes, you can use any one that you're comfortable with. I think this is an easy equation to use when you got this information, so I'm going to use this one. So we have here 18 plus 2.5 divided by 2 times 3.1. 3.1. Now that gives us 31.775. 31.775. So therefore we can say the distance between A to S, okay, the distance between A and S, okay, which is the difference between where he started and where he reached the sign, is going to be the sum of, it's going to be S1 plus S2, which is S1 we found was 10.8, wasn't it? Yes, 10.8. 10.8 plus 31.775, which gives us, add 10.8 to this, that gives us 42.575. 42.575 meters. That's an exact value. You can leave it like that. We don't have to round it. You could, if you want to. I'm sure they would accept 42.6 meters as well, but you can leave it like this. And that is the distance, okay, from the start to the stop sign. Okay, 42.575 meters. So that answers question number 7. It's actually quite a complicated question, really. It's not so straightforward, but you have to just keep thinking a bit straight here. All right, just think about suvat, think about the different sections where the acceleration is not the same. Here the acceleration is not the same as there. I can't take, for example, from A to S as one situation, because between A and C there's no acceleration. Between C and S, the acceleration is now -5. It's decelerating. I can't just take suvat between A and S directly. I have to take him as sections. Okay, so that's some things like that you have to think about in this question. So anyway, I hope that was clear. Other questions from this paper can be found in the playlist that will be showing at the end of the video in this region here. Other questions from this particular topic, which is kinematics and suvat equations, can be found in the playlist over here, and you can subscribe to my channel by clicking on the link in the middle. Thank you for watching, and see you soon.